Let's start with this example. So determine the output. So let's first see what this code does. First, we have a variable set to 5, then we call the method 0 on that variable. And 0 appears to set that variable to 0, so then afterward we print that variable once we're done calling 0. So with this print, well, if you thought it was 0, you would actually be wrong. It's actually 5. And why would that be? Why would the 0 method do nothing? This is why. We have I1 equals 5. Now, when I call 0 of I1, what that actually does is have n being set to 5. So really, when something is passed in, so like for example, when I1 is passed in, then the parameter would act just like the following way. Int n equals I1. So basically, when we pass I1 as an argument into the method, the parameter, basically we have this. So the parameter is not the same thing as the argument passed in here. Therefore, I1 is not changed because we just have n that's set to the value of I1. So we set n to be 0, and then we're done with the method, so n is gone. But then I1 is still equal to 5. So therefore, it prints 5. Here's an exercise. Determine the output of the following code right here. First, we have I2 equals 7. And then we have int I3 equals 1 of I2. So let's first break this down. In an assignment statement like this, we're first doing 1 of I2, which then returns an int, which I can set I3 to. So therefore, this is performed first. So then let's do that. So when we pass I2 in as an argument, so in this case it's 7, n, the parameter n is set to 7. So n equals 7. Now, inside the method, n equals 1. So n equals 1 right here, but I2 remains unchanged. And then now, I return n. So basically now, this value is 1 right here, so then I3 equals 1. And n is gone after the method's executed. So then the output would be 7, 1, as shown below. Now, what about this one? Well, let's see. So we first have S1 equals ABC. And then now we're calling 2 on S1. Now, what does that do? Well, when we call 2 on S1, S1 is an argument, so ABC is passed into the method, so S, the parameter, gets set to ABC. And then we do S equals 2, so therefore S gets set to 2. And then we print S, so then, in other words, we print 2. And then, afterward, S disappears because we're at the end of the method, and we see that S1 is unchanged. So then when we print S1, it's ABC, as shown below. Here's another exercise. What would this print? So for this one, let's keep track of the output again in the variables. So first of all, we have S3 equals QWERTY. And then we have 3 of S3. So therefore S3, which is QWERTY, is being passed as an argument to the method 3. So the parameter S3 right here is therefore set to QWERTY. Now, we may notice that actually these two are both S3. However, they're different even though they have the same variable name because they're in different methods. They're defined in different methods. So therefore, when we keep track of the output, it's probably better to like say, for example, somehow keep track of in what method they are. So variables in main method, and then right here, variables in the 3 method. And then right here, S3 equals QWERTY. And now we can distinguish between these easily by hand. And then now when we do S3 equals 3, we're inside the 3 method, so it's pretty clear right here that we have S3 is 3. And this S3 is not affected because it's different. And then afterward, we print S3. Now remember, when we print S3, we're inside of our 3 method, so therefore we print this S3. So we print 3. Then afterward, we're done with this method. So then, well, S3 is gone. And there's no more variables in the 3 method. And then now we go back to where I left off, which was calling this. So then I just print S3. And this time the S3 is the S3 in the main method. So therefore, QWERTY. And output's also shown below. And the next exercise, so what would this do? So first, we note that G1 is initially set to 7. So then afterward, I print G1. So then basically our output so far would be 7 because G1 is set to 7. Next, we perform the for method. So therefore, we go to the for method and we print G1, which is again 7. Then G1 gets set to 4. And notice that this time G1 is changed because G1 is being directly modified by here, this method here. So then afterwards, system.out.println G1, well, it's now 4, so it's 4. And even in the main method, again, it's 4. The output is also shown below. Now, here's an interesting example, though. What if we have, for example, something like this, where we have a static variable G2, let's just set it to 9, and then afterward, right here, G2 equals 5. Now, we do that and that, and now, right here. So what would this output? So let's keep track of everything again. So the variables and the output. And well, variables, we have static variables right from the start, so that we need to keep track of. So initially G2 equals 9. And then afterwards, we print G2, so that's just 9. We call 5 on G2. And now, this is where we have a parameter G2, so therefore we need to keep track of, so variables in the 5 method, we have G2 equals 9. And now, here's the thing. This G2 is different from that G2. And so which one do we print right here when we do system.out.println G2? Because both this parameter and this static variable can both be accessed. So therefore, what do? Well, it turns out it prints the parameter. Well, in this case, they're both the same, but in general, variables defined inside methods temporarily overwrite static variables. So basically, now inside of this 5 method, g2 refers to the parameter, not the static variable anymore. So therefore, now g2 equals 5, so the variable in the parameter becomes 5. And then we do system.println g2, that's 5. And then afterward, we are done with this method right here. We're done with the 5 method. And then we do system.out.println g2. And then we only have 9. Because the static variable wasn't changed. Over here, we changed the parameter. Here's the next exercise. Determine the output of this. So for this one, again, let's keep track of everything. We have u1 equals 6 and u2 equals 2. And now we call 6 on u1 and u2. So then basically, well, now we have I equals u1 and j equals u2, or basically as variables in the 6 method, we have I equals 6 because that's what u1 is, and then j equals 2. And then afterward, we have int temp equals I, so temp equals 6. I equals j, so I is 2. J is temp, so j is 6. And then, however, this doesn't really do anything because as soon as we're done with this method, all the variables are gone and we didn't change our original variables. So the output would still be 6, 2, as shown below. Now this has an important implication. Basically this shows that 2 local variables, so primitive data types in particular, cannot be swapped in another method. So basically if we have int right here, 2 ints right here like that, then basically the only way to swap them is to do it inside the method they're defined or used in. Of course, this is different with static variables because every method can access them. Swapping doesn't work for all primitive data types that are local in outside methods, so including double, long, char, boolean, and so on. And this also applies to string. Now let's go to the next exercise. What would the output be? So basically for this one, we have the following. ARR7 is an int array, basically 4, 5, 6, 7, 8, 9, like that. And so when we print the information, it's just going to be, so the length is 6, and ARR7 of 0 is 4. So like that. And then after we call 7 of ARR7, what happens? Well, we set ARR. So first, we pass in ARR7 as an argument, so ARR, the parameter, is set to ARR7. So it's equivalent to doing, again, int array ARR equals ARR7. So basically, what does that do? Well, that makes ARR point to this array. Like that. So now what happens when I do ARR equals new int array 77777777? Well, now all of a sudden what I'm doing is, well, we're directly doing ARR equals. So basically, whenever we have something directly equals, we change the pointer. So basically, ARR gets redirected to the 77777777 array, like that, and it doesn't change the original ARR 7 array. So therefore, the information's still going to be the same. Here's another example. So what would the following output? So basically, for this one, let's keep track of it again. So basically we have ARR8, which points to 456. And then we have ARR, which points to 456. The same 456 as ARR8 actually, similar to the previous problem. So now we're doing ARR of 0 plus plus. So what does that do? Well, that's equivalent to ARR of 0 equals ARR of 0 plus 1. So we're basically incrementing the 0 index element by 1. Well, what is ARR of 0? That is this thing. So we're incrementing that thing to 5. So before we increment it, the information would be, well, the length would be 3, and then the 0 index element would be 4. However, once we reach line 92, we call 8, so ARR gets pointed to this, the same array as ARR8. Then we do ARR of 0 plus plus. So what does that do? Well, now we have this element increases because we're not directly doing ARR equals. So therefore, we're not redirecting this pointer. ARR is still pointed to ARR, the same array as ARR8. So therefore, now the information is 3, 5, as shown below. So this shows that when you pass in an array, you can change the elements of the array if it's an outside method, even if it's an outside method. However, you cannot change the array itself if the array is local, as shown in the 7 example. Here's another exercise. So what would this print? Well, let's keep track of the output, and let's keep track of the variables. So first, in the main method, we have ARR 0, which is 4, 7, 8, 9. Like that. Then we call swap on ARR 0 with indices 0 and 2. So what are we doing here? Well, now we have a variable in the swap method, or variables in the swap method. So ARR is, well, it technically points to this array, but since it's not easy to do that here, I'll just say it points to ARR 0. It's the same logic. And now 0 is I, so I equals 0. And then 2 is J equals 2. Then int temp equals ARR I, so temp equals ARR of 0, which is 4. Then ARR of I, which is this element, equals ARR of j, which is that element. So now this is 8. ARR j equals temp, so we have that element equals temp. And then we're done. So then we're done with these variables in swap. And notice that the original array is modified because this ARR points to the same array as ARR 0, and I'm modifying the elements of ARR, not the array itself, the variable itself. So therefore, when I print it, it's going to be 8749, as shown below. And this shows that you can swap elements in an array. You just can't swap two arrays themselves, especially if they have different lengths. However, elements of arrays, you can swap. And here's the last exercise. We have this 9 method right here that takes in an array and then does this for loop. And inside the for loop, it's going to call other methods like swap and 8. And we have this code right here that calls the 9 method. So what will this print? So first, we have in the main method a variable arr9 that points to 2, 4, 3. And now, next we're calling 9 of arr9. So basically we're going to go to this method. So because we have a lot of calls, let's just keep track of where we're going back to. So that when we're done with 9, we can go back to this. So we pass arr9 as an argument, so therefore the parameter arr right here is set to arr9. So right here, variables in the 9 method, arr gets set to the arr9 in the main method. So then, now, what do we do inside of this 9 method? Well, we have this for loop. So first, I equals 0. 0 is less than 3. So let we go here. So call the swap method. So again, let's keep track of this so that we know to go back to here when we're done. So in the swap method, we passed arr as an argument, so the arr parameter in the swap method is set to the arr variable in the 9 method. So arr gets set to arr in the 9 method. And then I gets set to 0 and j gets set to this, which is 0 in this case. So j equals 0. And then now in the swap method, int temp equals arr of I. So temp equals, well, what's arr of 0? That's 2. So therefore, because remember that this arr points to the same array as the original. So temp equals 2. Afterward, arr of I equals arr of j. Well, arr of I and arr of j are the same thing, so we're just setting this thing to be 2. Then arr of j equals temp. Well, they're the same value. This call to swap doesn't do anything. So now, basically, we're done with the swap method now, so we go back to here. And now we call the 8 method with arr right here. So basically this arr in the 8 method is set to the arr in the 9 method. So basically all this does is increase the element at index 0 by 1. So therefore now this thing is 3. And now we're done with this 8 method. So let's go back to here. That's where we were. And now we're done with this iteration of the for loop. So I++, I is now 1. 1 is still less than 3. So now we're back here. We're calling this, so let's put a marker here again. So swap arr0i. So in this case, arr is again set to arr in the 9 method. And then I is 0. However, j is 1 this time. And now we do this code right here. So int temp equals arr of I. So temp equals arr of 0, which again is this, that's 3. Then arr of I equals arr of j. So basically arr of I, which is this thing, is equal to arr of j, which is this thing. So now this thing is 4. Then afterward, arr of j equals temp. So we're setting this element to temp. So this is 3. Or if you spotted it basically swaps these two elements. And now we're done with the swap method right here. So therefore, we go back to the 9 method we called it from. And now the next thing in line is the 8 method. Again, that just increases the element at index 0. So now this thing is 5, 3, 3. And then now we're done. So I++. So now I is 2. 2 is still less than 3. So therefore we swap on 0 and 2. We could do that manually again, or we could just notice that it's just going to swap these two elements as intended. So like that. And then finally 8, which we know is going to increase the element at index 0 of ARR, which is still the same array as this. So therefore now this thing is 4. So therefore we're done with this method. So when we're done with this iteration of the for loop, we go to I++. Suddenly I equals 3, and 3 is not less than 3. So therefore we're done with this for loop, and therefore done with this 9 method. And now we go back to where we marked, which is right here. And then basically now we're at this loop, and that's just printing all the elements. So it's just going to print 4, 3, 5, and then afterward it's just going to print a new line. So the output's just going to be 4, 3, 5 as shown below.